Here's a quick review of the midterm and how to do the problems. If you took the midterm in the testing center, you had a different version of the exam, so the numbers are a little bit different in your individual videos that I sent you. Um, uh, you'll see my comments there. But this is the general how to do the problems. First of all, sine of 3 pi over 4, you had to figure out where 3 pi over 4 was, which negative, sorry, 3 pi over 4 is 1, 2, 3 pi over 4 gets me down in the middle of the third quadrant. Drop a perpendicular to the x-axis, you got a 45, 45 right triangle in there. Anyway, 1, 1 square root of 2 with both the x and y negative. So the sine would be y divided by r, negative 1 over the square root of 2. Angle in standard position has its terminal side on the line y equals minus 4x. So this line right here in the second quadrant, so we're talking about that angle right there. Pick any point on that line there. So I just plugged in x equals minus 1, y equals positive 4, and y over x here, the tangent of the angle y over x is negative 4. So 4 over negative 1, which is 4. Most people got that. Let's see, number 3. Number 3, find all the angles whose tangent is 0.6, or if you had the other version, it was 0.8. Yeah, well, one of them is just their inverse tangent of 0.6. That turns out to be just under 31 degrees, 30.96. And so the tangent is, what's that, 0.6 over 1. There's also one down here in the third quadrant at negative 0.6 over negative 1. So just add on 180 degrees to that answer, and we're just under 211 degrees. Okay. This one right here, standing on a 200-foot tall cliff, or maybe 175, depending on your version. Angle of depression is 3 degrees. Angle of depression is from the horizontal down. Some people put it as a 3-degree here. That's the minor issue. The question is, did you see that the side you're looking for is this one? So if you put the 3 where it's supposed to be, then 200 divided by x is the tangent of 3. If you put it here, you would have said x divided by 200 is the tangent of 3. Either way, you got the general idea of how to do this problem. Anyway, I got 3,116. If you had the other version, it's like 5,011 or something like that. Anyway, well, that's number 4. Number 5. Number 5. Yes, we tell you that the sine of theta is in the first quadrant, and the sine is a over 3. So here's theta in the first quadrant with the sine being a, opposite side a, and the hypotenuse being 3. I asked about the cosine of 180 minus theta. So 180 minus theta is you got to turn 180 degrees and then back up theta. So you're looking at an angle whose terminal side is right over there. Well, that's kind of a mirror image of this over here. So a and 3 still fit in like that. Use Pythagoras to get this side here. Square root of 9 minus a squared. It's negative because you're in the second quadrant. And so the cosine would be x divided by r. So negative square root of 9 minus a squared over r, which is 3, right? Find an angle whose tangent is positive and whose sine is equal to minus a half. Well, tangent is positive in the first and third quadrant. Sine is negative in the third and fourth quadrant, so we must be in the third quadrant. And to get the sine equal to minus a half, that's minus 1 over 2. So that angle right there is it's a 30, 60, 90 triangle, so 30 degrees past 180 degrees. So you might have called it 210. Or you might have done it in radians, in which case you'd have said that's pi over 6 past pi, so 7 pi over 6. There we go. Number 7, in the triangle below, find the length of the side. Well, this is 27 degrees, the opposite side is 8. That's not the hypotenuse. The hypotenuse is down here, so that's the adjacent side. So a divided by 8 is the tangent of 27 degrees. A is equal to 8 tangent 27. And I got 4 point something. Okay. What's the radius for the circle? All right, so this one, we give you a circle and an angle of 20 degrees, which isn't very big. and it subtends an arc of length 10. You're looking for the radius, so S equals R theta. S equals R theta. If you plugged in S is 10 and theta is 20 and divided and said that R is equal to half, it's like, really? If this is 10, this is a half? I don't think so. Anyway, you got to convert the 20 degrees into radians first. 20 times pi over 180 is pi over 9. So you have 10 equals R times pi over 9, multiplied by 9, divided by pi, and you've got 90 divided by pi is R. Okay. It turned out to be about 28.6 something. Number 9. Now, those of you who got the testing center version of this, the numbers are a little different at this point, but the problems, they're in a different order, but their problems are essentially the same. Some of them are exactly the same, some of them just different things. Simplify here. I'm changing the secant into a 1 over secant x into 1 over cosine x, and then distributing the cosine x in. So cosine x times 1 over cosine x, and cosine x times cosine x, that's cosine squared x. Cosine x times 1 over cosine x is 1, so I've got 1 minus cosine squared x, but that's sine squared x. This one was a law of sines problem. So you've got two of the angles, 20 and 50. You can subtract from 180 degrees, 180 minus 20 minus 50, so that's 110 degrees right here. And so now I've got a over the sine of 20 degrees is 500 over the sine of 110 degrees. Multiply both sides by that denominator. And you've got 500 times the sine of 20 over the sine of 110, which turns out to be 181.985. Yay. All right, so that one, most people did just fine with that one. This one, there's a little bit of an issue. People have the right idea. There's just a matter of being careful that you don't get yourself in the ambiguous case here. With the information given, it takes the law of cosines to figure out side A. So a squared is 40 squared plus 50 squared minus 2 times 40 times 50 times the cosine of 30. Anyway, then you figure out that a is the square root of that. It's about 25.2. Once you know that, you can actually see 25, 40, 50. 50 is the big side, so B is the big angle. It's the only one that the law of sines might get wrong, and it does get it wrong. Because there's that ambiguous case. This is not an ambiguous triangle. This is a determined triangle. So B is only one of the angles that are the possibility that you get from that ambiguous case. So use the law of sines to find side C, angle C. It's not the biggest angle. The law of sines won't get it wrong. The only times the law of sines gets it wrong is if the angle is bigger than 90 degrees. This one's definitely not bigger than 90 degrees because B is the only one that might be bigger than 90. So I use the law of sines here. Sine of C over 40 equals the sine of 30 over A, and A was that 25.2. So anyway, plug it back in, and C turns out to be 52.477, and so B has got to be 180 minus 30 minus that 52 whatever, and it turns out to be 97.522. Okay. If you got an answer of 82 point something, I probably just said minus 2 and didn't even say what was wrong. Because really the only thing wrong was you solved for B using law of sines, and you got the supplement of what you should have gotten. Do 180 minus your 92, sorry, your 82, and it'll be this 97. All right, number 12. Yeah, sketch the graph here. I see amplitude 2. Actually, these are the answers down here too. Amplitude 2. The period is 2 pi divided by 2, so that would be pi. There's a vertical shift of 3. There's a horizontal shift of pi over 6. You got to factor that 2 out first, so that you're looking at an x minus something, not a 2x minus something. So factor the 2 out. You got 2 times the quantity x minus pi over 6, so it's a shift of pi over 6 to the right. So from the origin, I shifted over over pi over 6 and up 3. So I'm starting like this. I'm calling each square pi over 6 in this direction. And in this direction, I'm calling it 1. So if one of these is pi over 6, then 6 of them is pi. So pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, and 6 pi over 6. This would be all the way up to 12 pi over 6. That would be 2 pi. So I know that a sine curve is going to usually starts at the origin, but it's shifted over and up. So it's starting right here. It's an upside down sine curve because of that minus sign. And I know it repeats every pi. So from pi over 6, I move over pi. So to just pi over 6 past pi there. Get the point in the middle. At the 1/4 point, I'm either up or down, but since this is an upside down sign, I'm down the amplitude 2, and here I'm up the amplitude 2. And then I just, to draw an accurate graph, I just, well, I can see that every 3 things I'm putting a point, and then I'm alternating in between up 2, down 2, up 2, down 2, and I get those points in there first, and then I sketch the graph, and it comes out pretty good. Okay. So that kind of answered both of these questions there at the same time. Find an equation for the graph below. There's some things I see. I see, whether you think of it as a sine or a cosine, it's shifted down 1. So either any, I've got a bunch of answers here. Any one of them is correct, but they're all shifted down. They all have amplitude 4 from the midline up to the top or the midline down to the bottom. That's a distance of 4. So 4. Then are you thinking of it as a cosine curve right side up or upside down? A sine curve right side up or upside down? So I start off here and say, what if I think of it as a sine right side up? So starting right here like a sine curve would. So that's shifted 3 to the right. And I should point out, in any case, in any one of those cases, the period here from there to there is 8. And so the coefficient I need right here is 2 pi divided by 8. B is 2 pi divided by 8. So pi over 4 goes right in there. So thinking of it as a positive sign, this is going to be a pi over 4 x minus 3 because the shift is there. If I think of it as a negative sign, it's maybe shifted back to there, so I'm going to give it an x plus 1. So that shifts it to the left 1. If I was thinking it as a positive cosine, I think I shifted it back to there, so that would be an x plus 3 for the shift. If I think of it as an upside down cosine, I'm thinking of it starting right down there, so that was an x minus 1 for the shift. Anyway, I took any one of these, as long as you described it correctly. One of the things I should point out, it does say find an equation. If your answer does not include an equal sign, it is not an equation. It is an expression. And an expression does not give you a relationship between x and y. It just tells you something about x. I need to know that this is equal to y in order to be describing the points that are on this graph, right? Because this is saying you're on the graph if the equation is true, you're not on the graph if the equation is false. So if you don't have an equation, I don't know how to check whether it's true or false. So, number 14, how we go for time? We're going to make it. Okay, here we go. Find the exact value of the cosine of the arcsine of 12 over 13. So I've got an angle whose sine is 12 divided by 13. Opposite side over hypotenuse, 12 over 13. Pythagoras lets me find the other side. It is 5, as it turns out. And then I need the cosine of that angle, so adjacent over hypotenuse. 5 over 13 is the exact value, 5 over 13. Likewise, on this one, I've got the sine of the inverse tangent of x. So I have an angle whose tangent is x divided by 1. Opposite over opposite over adjacent is x divided by 1. Use Pythagoras to get that other side, square root of 1 plus x squared. And then I can take the sine of that angle. The sine is the opposite over the hypotenuse, x over the square root of x squared plus 1. This is an expression, right? It doesn't have an equal sign. It's just got algebraic expression of x. There's no trig involved in it at all. It's just adding, subtracting, multiplying, dividing, square rooting, squaring. And lastly, the arcsine of the sine of 3 pi over 4. Sine and arcsine are inverses of each other when you're in the right place, but when you're outside of when you're outside of that, they don't work. It's like squaring and square rooting. Are they inverses? Well, take -7 and square it. You get 49. Take the square root. What do you get? 7. You don't get back to -7. And this is what's happening here. When you take 3 pi over 4 and plug it into the sine, you get an output of 1 over the square root of 2. When you take 1 over the square root of 2 and you stick it into inverse sine is giving you the smallest angle that has that value for its sine. So I plugged in 3 pi over 4, but I get back pi over 4. And the arcsine of the sine of 3 pi over 4 is pi over 4. Okay. Anyway, this was a pretty good exam. I think people did reasonably well. Some people did very well. Some people did not so well. But on average, they did pretty well. So anyway, there you go.